welcome Prof. Rashid Al-Yahyai, and his presentation will be exploring natural oils from native plants to extend a fruit shelf life. Prof. Rashid, the floor is yours. I think we'll the anchor just to introduce Prof. Rashid.
Yes, sir. Thank you, sir. So we have an invited lecture by Professor Rashid Al-Yahyai. He's a professor of horticulture science at Sultan Qaboos University. He has more than 25 years of research and practical experience in arid-led farming, food production, post-harvest, sustainable agro-ecosystems. His publication exceeds 100 articles, book chapters, and books. So I request Professor Rashid Al-Yahyai to deliver his invited lecture on exploring natural oils from native plants to extend food shelf life. Sir, next 15 minutes, it's all yours. Over to you, sir.
Thank you very much. I will just start my presentation, share my slides. I think that will work. Do you see my slides now?
Yes, Prof.
Okay, thank you. Trying to hide this thing. Thank you, Dr. Nasser. Thank you, team of the conference. I would like also to appreciate the invitation to participate in this wonderful meeting and conference. It's a huge learning experience for all of us. Unfortunately, my voice is a little bit tired. I'm trying to speak as much as I can. I have a little bit of cold. I hope you excuse me for that. I would also take this opportunity to congratulate my colleague who is also a member of our team in this talk, Dr. Bankaj, for being one of the top 2% scientists most cited in the world, and that's an honor for us at SQU, and also being a colleague and also a team member of the post-harvest group at SQU. So congratulations, Dr. Bankaj. And also to get you started, this is the title of the conference is well chosen, especially on sustainability. At this time, as you know, there are so many issues, pressing issues around the globe that affects our way of life, the way we handle things, and so exploring our own resources is in a sustainable manner is the most important thing at this time. So our research with Dr. Bankaj, Dr. Rondo is also part of our team, extend to production and also whatever is after production to the post-harvest stage of produce, particularly for us horticulture crops mainly. But we also try to utilize our own resources. So here, this is actually the work of my postgraduate students, Engineer Layla Al-Yahyai, who is also work in this area, but has done tremendously good job in this project that I am very honored to present to you. And we have quite a few students who are helping us out. There are very few talented students in our labs, and so we appreciate their support and also their work, hard work. In these projects, this is one of them, is we try to explore natural oils from native plants to a variety of crops, including tomatoes and bananas and some other projects as well that are going on right now. And this particular talk will be about banana, utilizing two sources of edible oil that we probably, most of us are familiar with, probably consume for the most part, and that is olive and moringa. And we'll talk about this in details in the next slides. This is just a background information that we all have to eat at least 400 grams to stay healthy and well, and I think there is a growing awareness of the importance of eating fruits and vegetables across the world, not just in Oman, but also in many parts of the world, and that's driven by more health conscious consumers and their demands for healthier also foods, including natural and organic produce, as well as the way these horticultural crops, especially fruits and vegetables, are being treated post-harvestly are also of a concern to many consumers, and so there are ways to extend the shelf life. We try to make as much as we can from these products, but also there are losses that we acknowledge that we have to tackle, and we do work on the whole supply chain of fruits and vegetables. And so there are many issues that causes the loss of post-harvest produce. About in Oman at least, we know that 40% of it is lost at the farm level, at the production stage, but also at least 1/3 of that is lost after harvest. Once the produce is harvested and shipped until it reaches the consumers, we have plenty of losses caused by many conditions and reasons, including the climate, the conditions, the weather conditions, especially in hot climates like in Oman. The challenges are a lot more. The way people harvesting crops and the handling, especially like perishable produce like bananas and fruits and vegetables, the way they package it, the way they transport it, and Dr. Bankaj has plenty of research on the transportation damage that is caused to fruits and vegetables after harvest. There is also the pests and diseases along the supply chain. It takes it from the farm all the way to the consumer, and all of us have seen that, have experienced a variety of pests and diseases of fruits that are rotten and vegetables that can no longer be used, as well as the market. Also, the market contribute to this loss of about 1/3. So food security lies in addressing these issues. Actually, we don't. If we can tackle the losses and waste of food, we will probably be at a convenient food security for most of the world countries right now. So the whole idea, the whole concept here, is to try to extend the shelf life of these products, especially fruits and vegetables. Try to slow down chemical changes. Try to slow down transpiration from these produce, leading to less losses at whether it is at the storage level or the market level or the consumer level. Also, try to reduce bruises and injuries, physical damage to produce, as well as delay spoilage because of the bruises or because of pests and diseases or unfavorable storage conditions. So in this situation, we use banana. Why banana? Banana is very important globally. We all have banana at some stage of our life. I'm sure most of you this week had some kind of banana. And also, it is very perishable, very short-lived commodity that is being consumed worldwide. In Oman, it is very important. It is probably the most important after date palm. In terms of cultivation area, we have about, which is relatively not much comparable, for example, to India and many other countries. But for Oman, it is the second most important after date palm, and it is a very important cash crop as well. We produce about 18,000 tons. Relative to date palm, that is 300,000 tons. So that's quite different in terms of gap between banana and date palm. But still, this constitutes much more profitable to the farmers compared to date palm. And in a way, a lot of the practices are still traditional in nature in terms of cultivation, harvesting, and post-harvest management of banana in Oman. Harvesting is done at the green stage, as you would all know, also being ripened in different ways, in different conditions. So this is in Oman. This is one of the farms that is usually a model farm. This is actually wiped out completely by Shaheen cyclone recently, but it is getting back again. But the potential is there, as you can see, for a good expansion. If we process these bananas very well after harvest, then we have a big chance to reducing those about 60 to 70% losses, whether it is at the production stage or at the consumption stage. In terms of edible oils, why we are going for edible oils? They are available and there are a variety of plants. This is just experiment to check out what's the impact, how these edible oils are suitable for this kind of purpose at the local level. This is not yet at the industrial level, although there are applications for edible coating across the world, but this is for the purpose of local application. And we use olive oil because it is commonly available. It's also being now produced in Oman. as well as Moringa. But the difference between this type of Moringa that we have in Oman and also the other Moringa that is known as the Indian type oleifera, they are the same. They produce the same fruit, and they have the same edible and also medicinal uses. So this is an important oil producing plant that has been utilized for hundreds of years in Oman, and so it is potentially useful for this purpose. And why edible coating? Because a lot of the industrial wax and so many other applications are being now limited, especially in the European Union. The application of these kind of foods is not encouraged anymore, and in some countries it's totally banned. You cannot have synthetic wax, for example, in many European countries. So if you are going to expand on the production of banana to European markets or Australia or the US or organic markets, this is going to be challenging. In addition to the usefulness of the edible coating being a semi-permeable layer on top of the fruit, these coatings are actually have value addition in terms of being carriers for a lot of active ingredients. Like, for example, they enhance the color. They also have antimicrobial properties, and this has been proven for, especially for Moringa, whatever type of Moringa you have, both of them have antimicrobial, anti-fungicidal properties or fungicidal properties. Also, they are in some cases flavor enhancers, especially for people who are interested in that kind of flavor. And all of this can be manipulated in terms of concentration of the application of the coating. So that's why we have chosen also these edible coatings, and we test them out to see if it is practical to apply them on banana. Here in this situation, we applied them manually, tested a variety of physiological, chemical, and physical changes on the fruit. And so we looked at weight loss, color, firmness, total soluble solids, tetrable acidity, taste, tetrable acidity to total soluble solid to tetrable acidity ratio, pH, and mineral composition as well, to see if these edible coating contribute to potassium and other potassium, sodium, and calcium, basically, if they contribute. So we have these two sets of edible coatings or edible oils. Moringa is one, and olive oil as well. And we have control. We tested this from day 2 to day 12. We looked at batches, so we had like a standard batch, and every 2 days we would take a batch and analyze it. And that's what basically we have done, just using standard protocols that are being followed for firmness, for color, for weight, for sample preparation for bananas, the way you mostly familiar with. And we tested all of this. This is my student who has these pictures taken, so she wanted this to be here. But the protocols being followed and the analysis that been done. So let's get to the results. In terms of weight loss, we obviously the non-coated bananas had higher weight loss over the whole period of time, and that is expected, but there was no difference between those fruits that are coated with Moringa oil or olive oil. We used, I forgot to mention this, we used two types of bananas in Oman. The common one in most of Oman is Cavendish type, this Williams or the Cavendish itself. And Malindi is also another Cavendish banana, the same one that you see in the market, usually worldwide. But also the milk banana, which is a smaller one, that is a little bit, has some kind of plantain, so it takes a little bit longer to ripe, but it has a little bit shorter, longer shelf life. However, the skin is a bit, the peel is much thinner than the Cavendish. And we also, part of the study, we had it at room temperature, 25 degrees Celsius, as well as the standard storage temperature for bananas, which is 15 degrees Celsius. Obviously, when you store these bananas at higher temperature, they lose more weight, as you can see here. They lose more water, and therefore they also lose more weight accordingly. In terms of firmness, there is also significant differences between those treated with oil, coated oil on the left here, firmness, compared to the control, which has much less firmness than those two applications of oil throughout the whole time, like from day 1 until day 12. Similarly, because it is being a little bit more resilient, a little tough to handling, the milk banana had better firmness than the Cavendish, and this being throughout. Actually, from the start, as you can see, it is resilient. But over time, as it ripens, the firmness has declined, obviously. Same goes for temperature. Hotter temperature, here 25 degrees Celsius, had lower firmness. This is also expected for this type of banana, and we are talking here about coated bananas. Color changes almost consistent with other parameters like weight and firmness. Control always had faster loss of greenness. Basically, like the color change was a lot rapid compared to those coated, and I'll show you a picture in a minute of the fruits themselves, showing the changes over time in terms of peel color. Also, between cultivars, the color, both of them, of course, as they ripen, they both lose chlorophyll, and yellow color develops less green. They become less green. But as we started, the Cavendish had already almost yellow color, and the reason for that, this study was done during COVID, and movement was restricted, so we were not able to actually go to another governorate to collect samples from the farms. So we had to resort to samples from the market during that time, and that's why there are differences in the fruits, basically. But over time, the green color degraded, chlorophyll degraded, yellow color developed equally for both the Cavendish and the milk banana. The opposite of that, of course, the yellowness, but you can see again the development of color of yellow is faster in the control compared to those fruits that are coated with either moringa oil or olive oil. Not much change, or like it was not conclusive because of the color development. Degradation of chlorophyll was obvious, but the development of the yellowness, which is very strange to me, even it cannot be explained, but was not very clear. Although there are significant differences between the two samples, those samples from both the coated and non-coated, also from both cultivars, Cavendish and the milk, as well as those stored at 15 degrees Celsius, which is a storage temperature, or at room temperature. So to sort this out, we used chroma and hue colors. For chroma, it was obvious that the control had slower color development over time. I'm sorry, it was rapid, not slower, and the more consistent, longer, pleasant development of color was that for the bananas that are coated with oil, whether it is moringa or olive. There were no differences between those coated with moringa or coated with olive oil. So that is very good for us, good results. In terms of Cavendish, the same thing. There are significant differences in color development in chroma between the Cavendish and the milk. If you notice, the color of the banana, especially you'll see it in the pictures, that Cavendish has, clear, brighter yellow compared to the milk banana, which has a little bit toward the greenish side. In terms of temperature, the higher the temperature, the faster the color develops, the yellow color develops. That means we are losing the fruits much faster. That same concept goes for hues, which is arctan B over A, because this integrates both the yellowness and the greenness. That's the whole point of doing this analysis. Basically, we're trying to see if the oil will extend it will slow down color development, thereby by slowing down degradation of the fruit, breakdown of the chlorophyll, will give us better colors over much longer period of time. And if so, what cultivar that would be and at what temperature. And as you would expect here, we have here the results. We don't have the interaction because of time constraints, but there is interaction because all of these are significantly different. So there are differences in color development of the milk banana that is produced usually in southern Oman, in Salalah. It is much slower because I believe it has a bit of plantain in it compared to the Cavendish. And also at higher temperature, we have chlorophyll degradation much faster, thereby the development of the yellow color, and eventually the black dots on the fruits, as you can see here. This is the top one is the Cavendish, the top 2 rows. The bottom 2 rows are the milk banana. You can see the small bananas are can sustain much longer, even beyond 12 days of the experiment. However, the Cavendish banana, especially at room temperature here, you can see it has already developed to the maximum, basically under the control conditions. But under oil, they were still in acceptable color and in acceptable shape, even 12 days. Perhaps it can take you, so application basically it will take you probably to about 2 weeks from this stage. Although in the initial stage, as I mentioned, as you can see here, the color has the second day, the color already developed, especially for this fruit, for the Cavendish. So even though the color has developed, we expect if the color has not developed already, that will be a lot longer than 2 weeks. This shows the impact of the oil. In terms of chemical properties, the same thing goes as far as the control compared to oil coated bananas. However, I think it has to do with the fruit itself in terms of cultivars as well as in terms of temperature. Why the pH has shifted in both, why it declined in one and not the other. However, the trend in general for control compared to the edible coated fruits, the pH is much lower, more consistent in the coated plants or the coated fruits. Not sure why this goes back. In terms of total soluble solids, because they are rapidly maturing, the control is higher TSS compared to the development of TSS in the oil coated. As you can see here, it's going, but they are all the accumulation of TSS is continued, so it will perhaps continue even more later on as we go along up to a certain point. And also for Cavendish, milk banana, as you can see, milk banana is known to be it's a bit starchy compared to the Cavendish. However, after 8 days, it tasted or it had more TSS, and therefore it tasted much better than the Cavendish. The Cavendish had not, once it reached day 8, that's it. It hasn't changed. But for the milk banana, because this type of banana has a longer shelf life, it continues to have a better increase in total soluble solids. The same thing goes, of course, as you expect, in response to higher storage temperature. This is the tetrable acidity. The tetrable acidity almost consistent for all of them, except in the Cavendish and the milk. The same, just like with the total soluble solids. As we have higher soluble solids in the milk banana, we had lower tetrable acidity, and that's expected. We did not find differences. We thought that application of, because of the richness in at least in potassium, the Moringa oil and perhaps the olive oil would have an impact, or some, especially banana being like semi-permeable coat or semi-permeable peel. Some of that will be absorbed by the peel and may reach the pulp, but that was not the case. There were no significant differences between cultivars or between coated or non-coated fruit, as well as between temperature. So, however, as you are aware, maybe some of you who work in post-harvest of bananas, that the peel had higher concentration of all potassium, sodium, as well as calcium relative to the pulp. But this is the average for the day 6 and day 12. What you see here, the average of, we did 2 times at day 6 and at day 12, and these are the average of these two dates for all cultivars under all conditions. So basically, if you ask me, I would rather eat the peel than the pulp if I'm looking for potassium, sodium, or calcium. So, is it worth it to investigate more the effect of edible oil coating on crops, horticultural crops, basically fruits and vegetables such as banana? Yeah, the answer is yes. Is moringa a good alternative? Yes, moringa is a naturally found crop that grows worldwide, whether it is the Indian species or the Omani species, and these two crops are available. People know how to extract oil from it already. They already been used, the leaves are already been used, so it is readily available for this purpose. It needs to be further developed, of course, into like something that mechanically can be applied at the industrial level. Would it improve the quality, post-harvest quality of banana? It did improve firmness. It did improve the shelf life in terms of lower weight loss, lower transpiration, obviously. Also, it slowed the color development, chlorophyll breakdown, the development of the yellow color of both the Cavendish as well as the milk. So it can be applied on a variety of banana cultivars, and it can help increase the shelf life. So basically, what I'm trying to say here, for sustainability, we need to look for local solutions, and local solutions are available. And things like edible oil coating is highly sustainable because it's already readily available. People know how to plant moringa. They know how to extract oil from moringa. Banana is an important crop worldwide. I'm sure India is one of the largest producer. Oman is the second most important crop. Therefore, application of such edible coating, developing this technique or this technology, can have good outcome on both local banana production as well as industry. And with that, I would like to thank you and obviously encourage you to eat more fruits and vegetables. Thank you, Dr. Nasser. It's been great having you here, and thank you for all of you. I appreciate your feedback. Thank you.
Thank you, Prof. Rashid, for the nice presentation and very informative. We'll start this session for the questions, if any. Okay, so I will start with myself, Prof. Rashid. Here, I was just wondering why the olive oil, is it feasible? Because with moringa, it is, yes, it's very readily available. I was just asking myself about the olive oil. Will it be feasible to use as a coating medium for the banana?
Yeah, as you know, Dr. Nasser, there are about 3 types of olive oils that can be utilized for this purpose. The first one is probably not worth it, the extra virgin olive oil. The virgin olive oil, yes, and then the pomace type, the third option, which is like the lowest grade, usually is not being commercialized as an olive oil that's being consumed like the one we see in the market. The pomace rarely being used for that. That can be utilized for this purpose, and it makes economic sense, especially if it will have an impact on extending the shelf life of the produce. We tried it, by the way, on tomatoes and also on bananas, but I'm here presenting the banana side from Leila's experiment. But if you look at these 3 grades of olive oil extraction, extra virgin obviously will not, or is not, it's probably not worth it. But virgin and pomace especially can be useful. But here the point is not to just talk about these 2 oils, although the experiment was done on these oils. This is like an eye-opener to explore since there is no difference between moringa and olive, I would imagine, because the functionality of the oil itself, I'm not an expert in oils by any sense of imagination, but I expect that edible oil from other sources that are probably cheaper will also, like sunflower oil or some edible oil, that would not will enhance the taste, because we have to consider also these oils would have to have these properties too, because we want these oils not to just preserve the fruit color or the fruit taste, but also we want them to have added value in terms of enhancing the color, enhancing the flavor. It has some antimicrobial properties, so they will function to increase the shelf life of the produce, in addition to reducing, or enhancing the physical and chemical properties of the produce, and also have these properties. So I think these kind of oils are applicable to so many oils that are available in the market that are cheaper probably than olive oil. Although within olive oil, as I mentioned, pomace would be a really good candidate for this use, and the concentration will be very little. That will be up to the engineerings of this conference to look at, but I believe that there is a potential, especially now synthetic coatings, even wax, is being limited. And over time, consumer awareness will increase, and they will probably reject this kind of treatment to their fruits and vegetables. I hope I answered your question, Dr. Nasser.
Thank you, Prof. Rashid. I agree with you. And this is as an example of the American apple, where they are coating it with the edible coating wax to give the attractiveness and a shiny color. My second question here is, I was just wondering regarding the chemical parameter that you have measured. Did you measure only the peel or also the pulp?
No, these parameters are for the pulp. I'm sorry, I did not make that clear. These parameters are for the pulp, not for the peel. Okay. But if you are talking about the potassium or calcium, and no, for both the pulp and the peel. So this is the average of all. Actually, we have a much longer table here, but I thought we'll not introduce it. Just too much information, as you can see here. But we had it for the control, for the moringa, for the olive oil, and you can see here the differences. For example, if you look at the potassium, you can see it here for the cultivars and for the temperatures, and we have done it for the peel and also for the pulp. So for all, but there are no significant differences, and that's probably why I did not present it. However, we have done it for all.
Thank you, Prof.
Yes.
Rashid.
But it seems like the peel had a lot more potassium, sodium, and calcium, which maybe this is also an opportunity to investigate how can we use the peel that's being thrown away most of the time relative to the consumption of bulbs that we have now.
Yes, yeah, I agree with you, Prof. Final question: was there any chance to did you do a sensory evaluation for the acceptability of the peel?
Yeah, no, unfortunately, during that time, gathering was not allowed. So we're hoping that inshallah, when I get back, inshallah, we sit together and we probably expand on this and explore further opportunities, because I think there is a good really opportunity to extend the shelf life of at least the main crops like tomatoes, cucumbers, and bananas using these edible oils. And sensory evaluation will be really good, because that would give you feedback on the taste. I would not imagine, since a lot of it did not seep through to the pulp in terms of banana. So I don't expect that the consumers would find significant differences in taste-wise. However, maybe in other crops like tomatoes or cucumbers, that would be an issue. But however, since these are actually mostly salad vegetables, and a lot of people are using olive oil just in their salad, so I think that will be an added bonus too. So potential is there. So inshallah, we can do that as part of future expansion of the study.
Yes. Thank you, Prof. Rashid. I think you are still in sabbatical leave. You are in UK?
Yes, inshallah, until the end of this year, January, inshallah, I'll be back with Allah.
Yeah, that's why I can see you are wearing something to protect from cold.
I'm cold too. I'm cold. The temperature is like 5 degrees here. So
Yes,
these days is fluctuation in temperature, fluctuation in everything, climate, economy, everything.
Thank you, Prof. Rashid, for the nice presentation and very informative. And we are glad you are here with us.
Thank you. I
Anything
appreciate the opportunity.
you want
Thank
to
you.
add, my co-chair, Doctor?
Thank you, Dr. Professor Rashid, for the so much informative and basic information you are giving. I think the participant and the student were present in the session maybe get some idea about the future research or basic research. So thank you
Thank
from
you.
my side.
Thank you, Dr. I appreciate the opportunity. Thank you. And I also thank my colleagues as well. I thank you all for inviting me to this conference. I wish you all the best.